So Newton's first law dealt with a situation when our forces were all balanced, net force was 0, and then the object was either at rest or moving at a constant velocity. The way it was moving, it will just keep moving. However, what if one of the forces is unbalanced, or a combination of forces creates a net force? Then our object will accelerate. So just for examples that to get our feet wet, we have two people pulling on an object. So 45 is greater than 20. So my net force is going to be 45 minus, not equal to, but 45 minus 20. And that will give me 25 newtons. My object is no longer will be moving at a constant velocity. It will be accelerating. And that acceleration, so the reason for acceleration in this case is our net force, the difference between the 45 and 20. So it's going to be 25 divided by my mass, 0.7 meters per second squared. Forgive me if I'm wrong. I'm just running off of the top of my head. Similar to this, we have, again, definitely on the surface, because I see my force of friction, and I have my pull being 25 newtons. That is my force of pull. And then I have my force of friction to the left. Then I have my force of gravity and normal force. These two, the gravity and force normal, are balancing each other out. So my object is not accelerating up or down. But force of pull, or push in this case, because it's pushed along the desk, is greater than force of friction. So 25 minus 22 will be my net force. And then if I divide that by mass, I will get my acceleration. So 3 over 12 is going to be 1/4. So 0.25 meters per second squared in the direction of a greater force. So in this case, we have a sled that is being pulled at 40 degrees. So make sure that you are not creating a surface incline. This is just a force that is at an angle. So I still have my force of gravity that way. Normal force is slightly less by this, my pull y, and then my pull x is compared to my force of friction. And something is telling me that it's probably not equal to it. So if I look at my forces vertically, I'm going to say that my normal force, if I wanted to find it, I could do force normal plus 75 would be equal to force of gravity. So vertically, this is in the vertical direction, or OY. You can say OY direction. Everything is balanced. Everything is great. Now, horizontally, however, if I look at my force of pull, which is 75 times cosine of 40, that will be my pull along the x. And then I would subtract 53 newtons from it. So this would be my net force. And then if I divide that by mass, so this divided by my 32 kilograms, that would be my acceleration. Use your calculator to figure it out. I might. Example 4, again, this is for everybody. So CP, come back to this. We have something that is being pulled, and there's force of friction, so definitely force of gravity down, force of normal equal to it up. Does it say which way? Nah, I'm going to say it's pulled to the left. So force of pull, and then definitely accelerating, so my force of friction is less than that. Net force equals mass times acceleration. And I know my acceleration in this case. So I'm going to say 58 times 1.25 will be equal to, and this will be my force of pull minus force of friction. Force of pull is 300 minus force of friction equals 58 times 1.25. So to find force of friction, I'm just going to say it's going to be 300 minus 58 times 1.25. Use your calculator to figure it out. Answer is going to be in newtons because it is a force. Example 5, mass times acceleration, which is 45 times 2.5, will be equal to force of pull minus force of friction. And in this case, they give me force of friction, which is 154 newtons. So I'm going to say force of pull minus 154. Then my force of pull is going to be 45 times 2.5 plus 154, whatever your calculator gives you in newtons, that will be your force of pull. CP, you're free to go. So that would be another one of those lovely mg like that, split into mgx and mgy. Mgx is not quite balanced, but mgy is. So here's my normal force, and this is my force of friction. So I know that it's going to be less because they asked me for acceleration. So mgx is going to be 25 times 9.8 times sine of 60. Then force of friction is given to be 86 newtons. So my net force is going to be 25 9.8 root of 3 over 2 minus 86. So this is my force mgx, all of this. That's just cosine of sine of 60, which is cosine of 30. And then this is my force of friction, which was given to me. And I take that and divide by mass, and that will give me my acceleration. Then I have, again, the same case of mgx being greater than force of friction, normal supporting my mgy. So then my mass times acceleration, which is 42 times 4, so 168, will be equal to 42 times 9.8 times sine of, if this is 52 degrees, that is 52 degrees. Sine of 52 degrees, that's my mgx, minus force of friction, which is my question, force of friction, therefore. So then force of friction here is the difference between 42 9.8 sine of 52 minus 168, whatever that is. So Newton's first law was about this: when all forces were balanced out, a net force equaled 0. As soon as one of the forces is greater than the other, we are dealing with a net force that is not 0, and that will cause our object to accelerate.